A very good morning. Myself Kranti Gaurav. Today I am going to teach a very simple but a tricky topic of digital electronics, that is multiplexer. So let me start. What is multiplexer? Multiplexer is basically a combinational circuit, which means that it has more than one gates but no feedback and clock. Now it is a universal logic. It means that with the help of this combination circuit we can design any logic in the digital electronics. Simply, as we have universal gate, NAND and NOR, multiplexer is a universal logic. Now multiplexer is a parallel to serial converter. It means that it has parallel inputs and it gives a serial output. As I have written, many inputs and one output. Now it has a selection lines. With the help of these selection lines we find output by the input has been given. It selects one of the inputs and it gives the output. Here we have 2 raised to power n inputs, so we have n select line and one output. Now we will go further deep with a 2:1 multiplexer. Here, this is a logic circuit of 2:1 multiplexer. In this we have 2 AND gates and 1 OR gate. Here I have given S, which is a select line, as it has 2 inputs, so 1 select line. It is a 2:1 multiplexer. Now what I have done, here there is an inverted input, there is a direct input, and these are the I0 and I1, which are simple inputs. Now what has happened? Now the input has been given from here. So what we have done, when S is equal to 1, this second gate will be enabled and output will be I1. When input will be 0, then first gate will be enabled and output will be I0. And we can simply understand by this function table. When S is equal to 0, Y is equal to Y0, and 1, then I1. Now what will be the Y in terms of S? So S and I0. So Y equal to S per I0 plus S I1. This is the basic Boolean function of its output of 2:1 multiplexer. Now we will find the Boolean function of 4:1 multiplexer. Now see, this is the 4:1 multiplexer. Okay, in this we have 4 inputs. These are the 4 inputs, 1, 2, 3, 4, and 2 select lines and 1 output. Now how can we find the Y very easily? I will show you. Firstly take these 2 select lines and assign these numbers 0, 1, 2, 3. How? See, S1 S1 S1, okay, S1 dash S0 dash equal to 0. And how can we find other one? How? Simply S1 dash S0 equal to 1. Now S1 S0 dash equal to 2. Now S1 and S0 equal to 3. We have found. Now we have to find out Y. So how will we do that? Simply take it. Now Y equal to, see, nothing has to be done. We have find out 0, 1, 2, 3. So simply write the S1 dash S0 dash and I0 plus S1 dash S0 dash, sorry, S1 dash S0 I1. Okay, now plus S1 S0 dash I2 plus S1 S0 and I3. So this is the Boolean function of this 4:1 multiplexer, Boolean output function. Very simple and very easy. Now we will look into a problem. It's some hard problem. So this is the problem. Here what we have? We have A, B and C and 1 0. This is output I0, I1, I2, I3. It has been given. We have to find f of ABC. We have to find this. Okay, find out f of ABC. How will you find out? Same logic. We will do firstly S1 S1 bar S0 bar, it is equal to 0. So what we have there? We have A in the place of I0. So what we put? We put A. Now plus, now what is 1? So 1, how will write? S1 bar S0. Or now in the place of I1 we have A bar. So A bar. Now plus S1 S0 dash. Now in I3 what we have? We have 1. So 1. Now last but not the least we have S1 S0 and what we have? We have 0. So as we all know, we will simplify it. What will be left? S1 or S0 bar A plus S1 as S0 A bar, this is 1. So 1 into, we know that what will happen? It will have S1 S0 dash plus, this is 0, so nothing. So this is the final answer. Now this is not the final answer. What has been asked in the question? F in terms of A, B, C. So we will replace S1 and S0 by B and C. So this will become S1 is B. So B, C, A, now plus S1 B bar, C, now A bar plus B, C. So this is the final answer. Very simple. Now we will find out how many lower order mux are required to implement higher order mux. For example, we have to design 16:1 mux, 16:1 mux with the help of 2:1 mux. 2:1 mux. So there is a simple formula. What we have to do? Take 16, okay, divide by 2 equal to 8. Leave it. Now 8 divide by 2 equal to 4. Leave it. 4 divide by 2 equal to 2. Leave it. 2 divide by 2 equal to 1. Now further we cannot divide. Now simply add these numbers. What we have to do? Nothing. Simple. 8 plus 4 plus 8 plus 4 plus 2 plus 2 plus 1. 8 4 12, 12 2 14 plus 15. So equal to 15 is the answer. Simple. Now one more example. Suppose there are 32:1 mux. Okay. Now question can be asked that how many mux are required? How many 8:1 mux are required? So 8:1 mux. So we will simply what we do? We will take 32. 32 divided by 8 equal to 4. Now 4 cannot be divided, so we will put 1 there. Here division doesn't happen, so 4:1 we will take 1. This point you have to remember. Okay, now answer will be 4 plus 5. 4 plus 1 is equal to 5. So this is the basic concept of how you can find how many mux are required, how many lower order mux are required to analyze the higher order mux. So this is the basic concept. Now